Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is populating next right pointers in each node. This is another binary tree question. In each node, two. So somewhere in Leetcode, there's probably a populating next right pointers in each node. One, I haven't seen it, and it's not in the must-know questions, but this is rated as medium. Okay. Yeah, there's not. I don't think there's going to be anything like really complicated going on. There's 3 pointers that we need to keep track of, but yeah, that's the hard part is keeping the pointers straight, keeping the pointers updated, so we can traverse the tree. All right, given a binary tree, this is not written in Java, but in Java we'll have a class. Well, you can see the Java class on the right there. Each node is going to have a value. It's going to have a left pointer, a right pointer, and a next pointer. That's not really going to make sense until we see an example. Populate each next pointer to point to its next right node. If there is no next right node, the next pointer should be set to null. Initially, all next pointers are set to null. So really, we don't ever have to set a next pointer to null. We can just, leave the next pointers. We can leave the appropriate next pointers already set to null. I don't know. This is a good time for an example here. Okay. We need to what they mean by next pointers, next right pointers. It's horizontal pointers. Okay. So you look at the top level there. Is there a node to the right of 1? No. So the next right pointer is going to be null. And it's really not accurate to say we're going to set it to null. We're just going to leave it at null. It's already set to null. Looking at the next row, the 2 does have a node to the right, so the next pointer of 2 will point to 3, and 3 will stay at null. And finally, on the bottom row, 4, the next pointer of 4 will point to 5, next pointer of 5 will point to 7, and next pointer of 7 will stay at null. All right. I'm going to try to sketch out the algorithm. I think the first thing I need to do is make this a little bit bigger. All right, so there are our 3 pointers: previous, next, and current. What do those mean? Previous is the previous node that we processed. Next is actually the first node on the next horizontal level. Okay, and current is the current node that we're processing. All right, so when this thing starts, it is past the root of the tree. So the current node, it is going to be, you know what, I think I forgot to change the color there. All right, the current node is going to be 1. All right. Previous, there is no previous node. Next is the first node on the next level. We don't know what it is yet, but we know the current node, and it's 1. All right. While the current node is not null, we're going to call a helper routine, a modify routine on the 2 subnodes of the current node. That would be 2 and 3. Okay? So we'll call modify first with 2. And this is going to be a little confusing because once you get into the helper routine, then current really becomes, not 1 anymore, but whatever you passed in. I think I'll just like keep it over here and say 2. So that is the current node as far as the modify procedure is concerned. What do we do in modify? We check for the current node being null, which it isn't. We check for the next level, start, the next pointer to be null, which it is. And if it is, we set next to be the current node, which is 2. So you see how that's going to work. We're processing the top level, which is just the one node. The first node in the next level is going to be 2. All right, if previous is not equal to null, well, previous is equal to null because 2 doesn't have a previous node, previous in the sense of a node to the left of it. And then we set previous to the current node meaning the 2 here. All right, 2. Next thing we do is we call the modify procedure again on the right subnode of the current node. Current node is 1, and we are going to call the modify procedure, and we are going to pass in 3. All right, check for current node equals null. It's not. Check for next level start equals null, and it's not. Check for previous equals null, and it's not. So in that case, we set the previous dot next to the current node. All right, I'm gonna have to change colors here. Previous is 2. So previous dot next is going to point to the current node, and by current I mean current with reference to the modify procedure. It's going to point right there, the 3. Okay, and then we are going to set previous to the current node. So previous goes away here, and it gets set to 3. Okay. All right, so current node 1, we have processed current node 1 because we have processed the 2 subnodes of current node 1. So we're done with current node 1, and so we set current to current dot next, and current dot next is null. All right. So isn't that the eraser? Why can't I erase that? Oh, okay. It's null. That takes us out of the inner loop. When you see the implementation of this, it's going to be nested loops. There'll be a loop that processes the whole tree, and there'll be a loop that processes each horizontal level. All right. We then set current to next because that's the start of the next level. Okay. See if I have to change colors here. No, I don't. Current gets set to next, and that is 2. Okay. Previous and next get reset. The next level, the first node on the next level, we don't know what it is. Previous. The 2 node doesn't have a previous. There's nothing to the left of 2, so that is gone. All right. Now we're going to process this level 2. That means we are going to process the left and right nodes of 2. So the left node of 2 is 4, and it gets passed into the modify procedure. I'm going to write it down here. 4. Okay. Is the current node null? It's not. Is the next level null? It is. So that means we set the next to 4, which is going to be the first node in the next level. Okay, is previous null? It is, so we don't need to do anything with that. We set previous to the current node of 4. All right, we're done with 4. We are going to pass in the right subnode of 2, which is 5. All right. Is the current node null? It isn't. Is the next node null? It isn't. Is the previous node null? It isn't. So that means we need to set previous.next to the current node. All right. Previous is 4, so previous.next is going to be current node, which is 5. All right, and then we set previous to current node. Okay. And that will go here. All right. So we're done with the 2 node. Current level node. Current level node. Current level node next. Let me think about this for a second. Okay, that is the next step. The next step is that the current level node, the current node, gets set to current.next. Current.next is 3. Current is 2, and current.next is, make sure I got the right color. Current.next is 3. Okay. Now we got to process node 3. We got to process the left subnode, which there isn't one, and we got to process the right subnode, which is 7. So 7 goes into the modify routine. Take that out and change it to 7. All right, what do we do in modify? Is the current node equal to no? No. Is the next level start equal to no? No. Is previous equal to no? No. So we got to set previous.next to current. Previous is 5, right? So take that. 5.next equals current. All right, and then we set previous to current. So previous goes away here. This goes away here, and we will set previous to 7. All right. That's it for the modify routine on 7. Current level node equals current level next. Current level next, well, current is 3, and so current next is no. So that is gone. Next, current level next equals next. Well, next is now going to be, what color have I got on the pen? All right, that's right. Current next is going to be 4. And what that means is we are going to go through, I mean, the algorithm will actually go through and process 4, 5, and 7. There are no sub nodes of 4, 5, and 7, so nothing is going to happen. This is going to be the final result, 1, 3, and 7. Because they're initialized to null, they still point to null. All right, let's look at an implementation. I'm going to add a couple of class variables here. This is optional. If you want to pass the if you want to pass these variables to the modify the modify method, then you don't need to define them as class variables. You can just pass them every time. But I'm gonna pass it. I'm gonna pass them up here. And actually, let me just do that. Let me do it like that, so it's the way it looked in the sketch. Previous and next. Okay, so node cur equals root. Okay, it's not a good idea to mess around with root variables when they're passed into a routine. Just keep it so you always get a pointer to the root. All right, now let's say while current is not equal to null, and eventually this will run all the way to that null pointer to the left or to the right of 7 and terminate. This is the outer loop. This is going to process the whole tree. We can say previous equals null because there is no previous for the first node. We can say next equals null because we don't know what it is. And nested loop. Again, while current is not equal to null. The inner loop will process the inner loop will process each row. And it'll end when it gets to the null at the end of the row. We'll call the modify routine, and we'll call it first on current dot left. And we'll call it again on current dot right. Okay. When we're done processing the current node, we move to current equals current dot next. That continues to move across the row. Eventually it will hit the null at the end of the row. Okay, what else? And then when it hits the null at the end of the row, we want to go to the next row. So we'll say current equals next. Next is the pointer to the first node in the next row. Okay. And then what do we return here? I guess we just return the root. Let me double check that. Given a binary tree, initially everything is okay. You may use only constant extra space. I didn't even look at that. Recursion, however, is fine. I don't know if this really counts as recursion. Implicit stack space does not count as extra space for this problem. Okay. Yeah, I can't think of anything to return other than the root of the tree. Return root. All right. we need another method here. This will be private void, call it modify pointer, and node, call it something besides cur because that's confusing. Node, current node, and we'll say if current node equals null. We don't do anything, just return. I don't think we hit that in the walkthrough, but I mean, I think you would hit it. Well, you know what? Yeah, you would hit it like when you tried to do the modify left sub node of 3, you would hit it because it's null. So you would come in here and say it's null, return, and then also all the sub nodes of 4, 5, and 7. If next equals null, next equals current node. Yeah, we saw that in the example. If previous equals, now let's do it this way. If previous not equal null, if previous is not equal to null, then we've got to set previous dot next to the current node. These are nodes going across the row. So if you're going across a row and you have a previous node in that row, you've got to set the next pointer for the previous to the current node. Okay? And then we'll set previous equals current node. In case there's more nodes, then previous will be, this node. We'll get to the next node. And what's currently the current node will then be the previous node. It's, yeah. Do we need anything else here? I think that's everything that we did in the algorithm. I don't know. I'm going to run it. I'm a little nervous keeping these pointers straight. Line 51 is wrong. Oops, that needs a semicolon. All right. Accepted. All right. Base cases work. And submit. The study plan. Okay. So we had, we're in the middle. 0, 1, 2 milliseconds. This thing about, what is it? Oh, there it is. Populating next right pointers in each node. Yeah, the thing about the constant space, I'm not sure what they were getting at there. I think they just didn't want you to, build an entirely new tree. They wanted you to traverse the tree that you were given. So we're okay on that. And that's it. I hope you enjoyed it. Feel free to like, subscribe, comment, and see you next time.